Hello guys, happy Thursday if you're watching on Thursday. Short and I would say very easy lesson today, quiz tomorrow, so well over the hump for this week. Give the video a little pause, try this out. This is from Monday's lesson. Alright, so you were looking for an LCD. Should have been 5 MP, and then that should have given you 15 plus 4p over 5 MP. Pretty easy. Okay. This is a lesson that would be a little bit more involved if we could graph, but I'm not a huge fan of graphing these anyway. They're kind of sloppy. There's not too many points that sit too well on the graph, so this works pretty well. So just to talk about the overview of things here. This type of graph, if you look at the one you have there, is called a hyperbola. Okay, so we've seen parabola, obviously, just a U shape, but this is a hyperbola. You get it by dividing by x. Okay, so if you have, like the parent function says 1 over x, you're going to have a graph that looks something like that. And there's some other versions you'll see as well as we go through some examples. As far as domain and range, it says all non-zero real numbers. Okay, you'll see a little bit more specifically what that's going to look like soon. And then the big idea we have today is these things called asymptotes. I know, kind of funny word. And I'll point out that f of x is really just y. In fact, I'm going to just put a y there because I think it's more straightforward, but they mean the same thing, obviously. F of x, that's just your function notation. What asymptotes are they're basically imaginary lines that our graph is not going to touch. Now, that's not like a super perfect definition because there are some exceptions to that rule, but that's basically the best way for us to visualize these. So in this case, we have two asymptotes. I'll just use this parent function. We have what we call a vertical asymptote right here on our y-axis, because if you focus on the blue curve, the hyperbola, as it goes up at the top there, it approaches the y-axis, but it's not actually going to touch it. And then same towards the bottom of that blue curve is getting super close to the y-axis, but not actually touching it. And then for basically that same reason, we have what's called a horizontal asymptote at the x-axis in this case. Same idea. Those blue curves, our hyperbola, are getting very close to the x-axis, but not actually touching it. Yeah, so those are in general what asymptotes are. So now the question is, if we look at something like this, well, let's start with the foundation, okay? Where is this not defined? And that's going to apply to asymptotes. So we basically did this last week. First thing, I don't know why this like randomly moves on me, but that's okay. First thing is we want to factor the denominator if possible, and it is possible. It's x plus 8, x minus 3. And so as far as where it's not defined, undefined, right, that means the same thing. So one way you get undefined is if your denominator is 0, so that would mean it's not defined where x is equal to negative 8 or where x is equal to positive 3. Because if I put a negative 8 in right there, negative 8 plus 8 is 0. That would turn your denominator into 0, and same with a positive 3. So for this particular question or problem, that would be all we have to say. Okay, and now we're on to stuff that's more what we're looking at today. So identify the asymptotes, domain, and range of the function. Those are basically going to be the only directions we have on these problems today. So I explained what asymptotes are. You can kind of see what these ones would be on the graph. I'm sure if I asked you to draw in some dotted horizontal and vertical asymptotes, you'd be able to do that. But how do we know where they're going to be? Like on this one, I obviously can't tell exactly where those are. The way to tell is, and I'm going to set this up. So we're going to do vertical asymptote, VA, horizontal asymptote, HA, and then we'll do domain and range. Okay, our vertical asymptote is wherever we have a value of x that would make our function undefined. So specifically what that means is I'm looking at the denominator, right? So first of all, they gave us the actual equation for the function there. When I look at the denominator of x minus 2, I need to think what value of x would turn that denominator into 0. And that's 2. 2 minus 2 gives you 0. So that means we have a vertical asymptote at x equals 2. And that would be this one, right? And again, that's why we have to do it that way, because if I get rid of all that, you can see it's pretty hard to tell whether that would be 2 or 3 or where it would be. Okay, but that's what it is. It's x equals 2 for that reason. Horizontal asymptote, the way, I want to explain the logic behind it, and then I'll show you the easy way to do it. Okay, so again, if I look at our equation, and we know that f of x is basically equal to y, okay, and our horizontal asymptote is always going to be y equals, just like our vertical asymptote is always going to be x equals. So I need to think to myself, where or what y value can I not get out of that function? It's basically the same question we're considering when we're thinking about domain and range, right? What y value can I never get? So you might start thinking through, but I won't waste time. The y value, just to clean this up, that we're never going to get in this case is 0, right? Reason for that is, as our x values get higher and higher and higher and higher and higher, our denominator is going to get larger and larger, right? So picture, if you had 3 over 3, that's just 1. If I had 3 over 100, that's 0.03. That's getting pretty small. 3 over 1,000 is 0.003. That's getting smaller. And the larger that my x values get, the larger the denominator gets, the smaller and smaller my y values get, my resulting y values. However, they're going to continue to get smaller and smaller and smaller, but they can't actually be 0, right? Because no matter how big the denominator is, it's still 3 divided by a number. So I can't get 0 out of that. So that's why the horizontal asymptote is y equals 0. Now the domain and range are super easy, because again, like I said, we're thinking about vertical and horizontal asymptotes basically the same way we're thinking about domain and range. So that means the only thing we have to say about our domain is that x is not allowed to equal 2. Because if it did, your denominator would be 0, so that's not allowed. And our range is y cannot be 0, because you can never get 0 out of this thing. So that would be all the information we need to include in our answer for this problem. Okay, looking to the next one. Same thing, I'm just going to kind of set this up. Vertical asymptote, horizontal asymptote, domain, range. Vertical asymptote, I'm looking what value of x creates a 0 in the denominator. That would be x equals -2. Now the horizontal asymptote, I can think similarly to the last problem. So this fraction right here can never be 0, but it's going to get really, really close to it. So if that was all I had, it would say y equals 0 again, because that's the value of y that I can never get. However, on this one, since we're adding 1 right there, look at all those little dots. Since we're adding 1 right there, it bumps it up 1. So it's y equals 1. So what we've learned now, or what you will be seeing, is the vertical asymptote, again, is whatever makes that denominator 0. That's pretty easy. You guys are pretty good at that at this point. The horizontal asymptote is y equals whatever's being added or subtracted to the fraction every time. So this is y equals +1 because you're adding 1. And the domain and range are super easy because they're the same things, but not equals, because those are the values that you cannot get for x and y. So final answer to that one. And now I'll do these or this last, oh, there's not even a last problem. Well, hopefully that's all you need. I think once you see that relationship, it should be super easy, and you'll get more practice, obviously, on the huddle. I included this just so you can see this slide that we've seen, over and over again. Kind of shows up here. So it talks about, it's moving it right or it's moving it left or up or down or whatever the case may be, but you don't really have to pay attention to this. Okay, so huddle is here. So the first two, I left the graphs in there. You could see we're not really using the graphs because, again, it's hard for me to tell if I look at that graph in number 1. I can't tell where the heck the vertical or horizontal asymptotes are. It looks like I can maybe see where the horizontal asymptote is, but not super helpful to have the graph anyway. So first 2 have them. Last 4 do not. Give this a try. And I want to point out one thing too, just before you get confused about this. If I have a -1 up there, it doesn't matter if it's a -1, doesn't matter. In one of our examples in the notes, we had a 3. It does not matter what number is up there. It's still going to work the same way that I just explained. Okay, so don't worry about that. So pause the video, give those a try, and then I will read off the answers. Once I find them. Okay, here they are. All right. Number 1, vertical asymptote, x equals 1. Horizontal asymptote, y equals 0. Domain, x not equal to 1. Range, y not equal to 0. Number 2, vertical asymptote, x equals 0. Horizontal asymptote, y equals 4. Domain, x not equal to 0. Range, y not equal to 4. Number 3, vertical asymptote, x equals -3. Horizontal asymptote, y equals -3. Domain is x is not equal to -3. Range is y is not equal to -3. Number 4, vertical asymptote, x equals -5. Horizontal asymptote, y equals -6. Domain, x is not equal to -5. Range, y is not equal to -6. Number 5, vertical asymptote, x equals -1. Horizontal asymptote, y equals 3. Domain, x is not equal to -1. Range, y is not equal to 3. And last one, number 6, vertical asymptote, x equals -4. Horizontal asymptote, y equals -2. Domain, x is not equal to -4. Range, y is not equal to -2. Hope that went well. Should be the easiest lesson of the week if you're getting what's going on. And then mastery is just these 3 problems, all of which have a graph, but again, that doesn't really make much of a difference either way for you. So do those 3 for the mastery. That is called 8-3 mastery if you're looking for it. And then homework assignment is here. And as it says, for all problems except number 50, find the asymptotes and state the domain and range. Do not graph. So I'm looking for the same 4 things that we did on all these problems. For vertical asymptote, horizontal asymptote, domain, and range. I'm specifying that because at least 1 or 2 of the questions, I think, just say find the domain and range and graph. I do want you to find the asymptotes in addition to that. You see that this does not take long and it's not difficult, so that should not be an issue. So, quiz tomorrow. Let me know if you have any questions before you have to take that. Hope all's well. Talk to you next week. Have a good weekend.